Very good morning. Am I audible?
Yes, sir.
Okay. So, in last lecture, what we have studied? So, we have covered the noise degradation model, right? So, we have clearly studied about the difference between the image enhancement and image restoration. Then we have studied the causes of restoration, right? What actually happens if we say, right, or someone says this image is degraded, that means what changes are happen to that image. That part also we have studied. Okay, if someone says this image is degraded, that means either its pixel locations are got shifted, right? This is the one cause or one thing. And second thing is the intensity values of the pixel may got altered or may got changed, right? And these are the two what you can say indication that that particular image is got degraded because of the noise, right? So this thing we have clearly discussed in the last lecture. So the last point of this unit number 5th is remaining. So noise models, right? So what are different noises that are affected or that affects the image, and that image is what we can say image is called to be a degraded version. Okay, so what are different noises? So that part now we are going to discuss. Okay, so the first part is image basic causes we have studied, right? Basic causes, there is a drawback or image acquisition techniques, right? Noises, whatever the noises we are talking about, that are mainly get introduced in this image while we are acquiring that image, right? That are we are calling it as a sensor noise, right? Or you can say image acquisition noise. So this is the main source of this noise. Again, now what are the this acquisition, or what happens during this image acquisition? So because of different environmental conditions, right? Quality of sensing element, this is one of the major cause, right? The what we can say, the device or the sensor through which you are going to capture that image, it must be of a good quality, otherwise you will get a noisy image or degraded image, right? During transmission. Okay, so image acquisition and transmission, these are the two what we can say major source, right? Or these two are the major causes of image degradation. Okay, next part is now we are going to talking about the noises. Okay, now we have some special property of noises. Now what is this special property and Fourier property of noise? So with a few exceptions, we consider that noise is independent of a spatial coordinates, right? Means always this noise is independent of the spatial coordinate, but there are some exceptions to this rule. Okay, and the second property is, we assume that noise is uncorrelated with respect to the image itself. That means there is no correlation between image pixel and the value of noise components. So these are the two properties that we consider for the spatial domain, right? These two properties of the noise that we can consider for the spatial domain. And now what about Fourier domain? So Fourier domain, again we are having the two properties, right? First one is a frequency contains of noise in a Fourier sense, right? When you plot a Fourier transform, see, Fourier transform is what? Frequency domain transform, right? Why we are taking Fourier transform of anything? To have the frequency domain analysis, or to have the frequency domain look, and that's why we are taking the Fourier transform. So but obvious, this Fourier transform is totally related with the frequency domain things, right? So it refers to the frequency contents of noise, means actually it shows the your original image, right? That is a function of frequency as well as the noise frequencies also, right? Means when you plot Fourier transform of your degraded image, you will get the two different components. First component is your image itself, and second component is noise, right? And if Fourier spectrum of noise is a constant, the noise is usually called a white noise. That means if you find that noise having the constant amplitude throughout your spectrum, then that particular noise is called as white noise. Okay, so these are the two what we can say special properties of noise and Fourier properties of noise. So before going to the actual what are different noises, we must know these properties. Now then we will talk about the noise probability density functions. Okay, so these many noises, right, that can be responsible for the image degradation, right? These many different noises that are responsible for the image degradation, right? So first one is a Gaussian type noise, second one is a relay noise, third one is a gamma noise, then exponential noise, then uniform noise, then impulse. That's impulse noise can be known as salt and pepper noise, then periodic noise, right? So these are the major types of noises that are affect your image, and so that we can call that image is degraded version. Okay, so one by one we will just look at its noise density function, right? So see, these are the all mathematical things, so you have to by heart these things. Okay, so this is a Gaussian noise or normal noise model. So what is this probability density function, how the graph of its PDF, that means probability density function, look like. So this is all things are given in this mathematical model. Okay, so you can say it's a mathematical representation of that noise. Okay, it's a mathematical representation of that particular noise. Okay, so this is probability density function of this Gaussian random variable is given by P of z is equal to 1 divided by under root 2 pi, right? Sigma e raised to minus z minus mu square divided by 2 sigma square. So what is sigma, what is mu, what is z? So all things are given there. Z is a gray level, mu is a mean average of that gray level, then sigma is a standard deviation, sigma square is a variance of z. So this is the mathematical formula to calculate the probability density function of Gaussian noise. Or by using this formula, you can perform or you can design the Gaussian noise model, right? By using this formula, you can design the Gaussian noise model. So this is about the Gaussian noise. Then the same thing is relay noise model. So again, we have this formula, right? Mu is equal to, sorry, P of z is equal to 2 divided by B, then z minus a e raised to minus z minus a square divided by B. See, this derivation is not there in your syllabus. Okay, so for your understanding, I have given here their mathematical functions or mathematical equations. Okay, you have to simply remember this. Derivation is not there. So what is z, again gray level, what is mu, what is sigma square, variance of z. So that part, the mathematical equations for each type of noise is given here. So this is for the relay noise, so this is for the gamma noise. See, the P of z is the main equation. P of z is the main equation. And what is P of z? Probability density function. What is P of z? Probability density function of that particular noise that is given by P of z, right? When z is greater than or equal to z, and remember always, z is nothing but gray level. Gray level is nothing but your gray level is nothing but intensity, right? Gray level and intensity is one and the same thing. Again, I will repeat this thing. Gray level and intensity is one and the same thing. That means z is nothing but the intensity of that particular pixel, or gray level of that particular pixel, that is represented by z. So this is a mathematical equation for this gamma noise. So this is mathematical equation for this exponential noise. This is uniform noise, right? 1 divided by b minus a, and for otherwise that means a within outside that range it is 0. So it is for uniform noise. So there are different types of noises that are introduced, and we can form the models or the noise models of that particular noise by using its probability density function of that noise. म्हणजे हे मॅथमॅटिकल इक्वेशन वापरून आपण त्याचे नॉइज मॉडेल बनवू शकतो, or we can design its noise model. And then noise model is nothing but what? Your degradation model, right? First we have to identify which noise, right, that causes that image to degrade it, and then after using these mathematical formulas we can actually design that noise model or noise degradation model to remove that noise. So this is the main purpose of using this noise models. म्हणजे आधी आपण माहित करून घ्यायचं की कुठल्या नॉइजनी ती इमेज डिग्रेडेड झालेली आहे, बरोबर आहे. मग त्या नॉइजचं मॅथमॅटिकल फंक्शन वी नो, राईट. सो वी हॅव टू design that particular noise degradation model for that particular noise, and simply we can remove that noise. त्या नॉइज साठी ते नॉइज डिग्रेडेशन मॉडेल बनवायचं आणि तो नॉइज रिमूव्ह करून टाकायचा. दिस इज अ सिम्पल यूज, or this is the simple way of using, or a simple way of implementing the image restoration, right? So this is about impulse noise, and here are some examples actually how these different noises are, what we can say, the noise histograms of that particular noise. So first one is, you can see it's a Gaussian noise, so its histogram looks like second image. That means image given below, it's a these are the histograms of that noise particular. Okay, second one is a relay noise. Below image is its histogram. Then third one is a gamma noise, then it's histogram. So exponential noise, uniform noise, saltpeter noise. So these are the different histograms of that particular noise, right? So these are the about different noises and its noise models. Okay, and with the help of these noise models, right, using its mathematical equations, we can design its noise model, and we can remove the noise from your degraded image, and we can restore back that image to its ओरिजिनल फॉर्म. म्हणजे त्या इमेज मधून नॉइज रिमूव्ह करण्यासाठी आपल्याला त्याचं नॉइज मॉडेल आधी बनवावं लागतं, अँड देन ओनली वी आर एबल टू रिमूव्ह द नॉइज. तरच आपण तो नॉइज रिमूव्ह करू शकणार आहे, आणि वी कॅन एबल टू रिस्टोर दॅट इमेज बॅक टू इट्स ओरिजिनल फॉर्म, राईट. दिस इज अबाउट द पिरियॉडिक नॉइज. ओके, clear with the same? So here unit number 5th is finished. समजलंय का सगळ्यांना? All of you understood?
Yes, sir.
Okay, fine. So this is about unit number 5th. Now without wasting a time, immediately we will start with the next unit, right? That is unit number 6th. Screen is visible?
Yes, sir.
Okay. So unit numbers, now our syllabus is actually divided into two parts, right? What is name of our course? Image and video processing. So up to this unit number 5th, we were talking about only image processing. Now in the remaining two units, that means unit number 6 and unit number 7, we are going to talk about the video processing parts, right? Some of the basics of video processing, some of the basics of video formation, then perception, representation, what are different algorithm techniques that we can use in the video formation or perception. So we will talk about uh, video processing in the remaining two units. Okay, so now we will start with the first, the part of that video processing, that is unit number 6. and it is video formation, perception, and representation, right? So this is the syllabus. Okay, digital video sampling, video frame classification, notation, ITU, video formats, digital video quality measures, then video capture and displays. We are going to study about different capturing devices, right? Cameras, then uh, color video principle, digital video principle, all that. Then we are going to study about some samplings of video signal, right? Because you know about the sampling, but in case of video processing also we require a sampling. Sampling we require not only in only audio signal, but with the video signal also we require a sampling. Okay, so now the first point of the this unit is working principle of this video camera. So all of you have studied with the, or all of you are more familiar with this video camera, right? In many occasions, normally to record the what we can say, the moments, to record the some precious moments of our life, we are normally using the video camera for different purposes, right? It has many purposes. Okay, from media to entertainment, from what you can say, uh, for media purpose to entertainment purpose, wide range of application we are using the video camera. Then now what is camera? So basically, camera is an electronic device which helps to capture moving and store images in into a storage device. So all of you know, if you talk about digital camera, so what is what we can say, what is there inside that digital camera? So it has some capturing lens, right? Then it has that conversion mechanism for analog to digital, and the digital part, okay, that digital part you can store into a memory. So it must have a storage device, that is nothing but a memory. So it have capturing part, then it have conversion part, and it have storage part. Okay, now types of video cameras. So you are much familiar with the analog cameras, that old age cameras, right? Where you used to use that what you can say, photo roll, right? Photo roll. Then when you are what you can say, as you are going capturing the images, that roll is sliding one by one, and your images are getting printed in negative fashion. Then you have to go to the lab, then you have to get that film wash, and then you can have your photos or color photos, right? आठवते का नाही? तुम्ही हेच करायचा म्हणजे इन युअर चाइल्डहुड मे बी अॅनालॉग कॅमेराज, फोटोचे रीळ मिळायचे, बरोबर आहे? ते आपण त्या कॅमेरात फिट करायचो. देन आपण इमेजेस कॅप्चर करत जायचो. मग तो रीळ घेऊन लॅबमध्ये जायचं, त्यांना तो रीळ द्यायचा, आणि मग त्याच्या तो रीळ धुवून आपल्याला त्याचे ते फोटो द्यायचे. दॅट इज द अॅनालॉग कॅमेरा. अँड नाऊ डिजिटल कॅमेरा मीन्स व्हॉट? यू हॅव दॅट SD card. What you do is simply you remove that SD card from your camera, give it to the uh, photo maker, or your photo lab person. He will simply read that camera. You will have the soft copies of images. He will make you print for that. He will print it for you. Very simple way. This is the digital camera, right? Then on the basis of use, you have different again you can categorize video cameras such as studio camera, then field camera. That means this studio camera is mostly used for the स्टुडिओ पर्पज. म्हणजे तुमचं एखादा आपले दूरदर्शनचे स्टुडिओ असतात, जिथनं तुमच्या न्यूज ब्रॉडकास्ट होतात. दीज आर द स्टुडिओज, राईट? सो there are some cameras used for the studio purpose, there are some cameras used for the field purpose. Field purpose means what? These particular cameras are mostly used for the reporters, बरोबर आहे का नाही? रिपोर्टिंग करताना त्यांना तो कॅमेरा घेऊन कुठेही फिरावं लागतं. देर मे बी अ फ्लड सिच्युएशन, देर मे बी अ सम ऍक्सिडेंट, देर मे बी अ सम what you can say incident event, there may be some celebrity may visiting that place, or there may be some minister visiting that place. So they have to get that camera to that field, and they have to capture the information. So these are the field camera. Then uh, prosumer camera is there. Then sting camera is there, drone camera. So drone camera you can aware of, it is fitted into a drone and it's normally captures the image from the aerial view. बरोबर आहे का नाही. ड्रोनवर तो कॅमेरा फिट केलेला असतो आणि तो एरियल व्ह्यू कॅप्चर करतो. इन्फ्रारेड कॅमेरा यू हॅव, नाईट विजन कॅमेरा, DSLR camera you have, right? Then spider camera you have, mobile camera that normally you use into your mobile. So these are the different categories of camera on the basis of use. Okay, now next, internal parts of camera. Now we will actually talk about the internal parts. So already we have discussed, it must have lens, right, to sense your, or to what you can say, sense the image or scene that you want to capture. Then it must have aperture part, then it must have shutter, then beam splitter, then imaging devices, right? That means sensor. Imaging devices means what? Actually the sensor, that may be a CCD, CMOS or XMOS. So these are the imaging devices, nothing but the sensor. Then viewfinder, then memory, that means storage device. So these are the main parts of the image. Now how or where these actually all these different parts are being fitted into an image. So this is a general view of the your camera, video camera. So this is the object, right? Then you must have the lens, then you must have a beam splitter. Now this is a capturing, that means this CCD sensor is normally used to actually record your image, right? This is the image sensor. See, lens and beam splitter job is to, whatever the image, the lens will actually what we can say, uh, focus that image light or the whatever the reflecting light. So lens will focus that light into a beam splitter, then beam splitter will split that light and it will transfer to a sensor part, and sensor part then, after sensing that light, it will record the image, right? And it will record and it will store to the storage device. This storage device is nothing but what? Memory, you can say. Okay, then what is about the lens? So it's actually a glass medium which gives proper direction to the light. That means it is used for the focusing purpose. जो ऑब्जेक्ट करून जो रिफ्लेक्ट झालेला लाईट आहे तो त्या सेन्सरकडे फोकस करायचं काम जे आहे ते लेन्स करतं. देन it determines what camera can see. बरोबर आहे. लेन्स it actually uses what the camera can see, that means what scene that you want to capture is. So it selects a certain field of view and produces a small optical image of object, right? This lens and next you can use the lens for the zoom purpose. That means to increase the size of object, that means to make that object closer to you or to make that object farther to you. So for that purpose also, that means zooming purpose also, we are using that lens. Okay, then what is use or what for the aperture is? So it's control the amount of light, right? Aperture that controls the amount of light that passes to the capturing device, that means your sensor. Okay, it decides the depth of field. So aperture decides the depth of field and it measured through f stop number, right? It measures through the f stop number. So this is the aperture, that means amount of light that you want to pass to the that particular camera to the sensor. Okay, now shutter speed. The length of time of shutter remains open to allow light to reach the imaging device is called a shutter speed. म्हणजे शटर स्पीड म्हणजे काय की किती वेळासाठी त्यांनी तो लाईट पास केला पाहिजे, अलाव केला पाहिजे टू द सेन्सर, दॅट इज शटर स्पीड. देन इट इज अ थीन शीट कव्हरिंग इमेजिंग डिव्हाइस. इमेजिंग डिव्हाइसच्या आधी ते बसवलेलं असतं, दॅट इज अ शटर स्पीड. Shutter speed is measured in a second or fraction of second, and using fast shutter speed, it is to capture fast moving objects and slow shutter speed for स्लो मुव्हिंग ऑब्जेक्ट. म्हणजे एखादं सपोज तुम्हाला धावत्या ट्रेनचं रेकॉर्डिंग करायचंय तर त्यासाठी तो शटर स्पीड फास्ट पाहिजे. आणि एखादं स्टेडी ऑब्जेक्ट आहे किंवा काय म्हणतात एखाद्या तुम्हाला स्लो मुव्हिंग ऑब्जेक्ट, एखाद्या सायकलीवरून जाणाऱ्या माणसाचं तुम्हाला रेकॉर्डिंग करायचंय तर त्यासाठी शटर स्पीड स्लो चालणार आहे. पण एखाद्या तुम्हाला धावत्या ट्रेनचं रेकॉर्डिंग करायचंय तर यू रिक्वायर अ फास्ट शटर स्पीड, राईट. फास्ट शटर स्पीड रिक्वायर अ लार्ज अपर्चर अँड स्लो शटर स्पीड रिक्वायर अ स्मॉल अपर्चर. बरोबर आहे. म्हणजे फास्ट शटर स्पीड ठेवायचं असेल तर अपर्चर सुद्धा लार्ज लागणार आणि स्लो शटर स्पीड असेल तर अपर्चर सुद्धा स्मॉल लागणार, कमी लागणार. ओके. देन बीम स्प्लिटर. व्हॉट इज रोल ऑफ बीम स्प्लिटर? इट कंटेन्स व्हेरियस प्रिझम अँड फिल्टर, राईट. दिस बीम स्प्लिटर कंटेन्स व्हेरियस प्रिझम अँड फिल्टर, म्हणजे एक प्रकारचं प्रिझम आणि त्याच्यात ऑप्टिकल फिल्टर्स असतात, राईट. You might have studied in optical filter. There are different beam splitter, or actually this part we have studied in optical communication, right? So the same working and same job is used in camera also, beam splitter, right? This prism breaks up incident light into a 7 colors. म्हणजे तो बीम स्प्लिटर म्हणजे एक 7 कलर असतो. आणि तुम्हाला प्रिझमचा रूल माहिती, प्रिझमवर जो कुठला लाईट इन्सिडेंट होतो त्याचं ते काय करतं, इट डिवाइड्स और इट splits into a 7 color. Then filter separates the white light into a 3 primary colors, namely red, green and blue. म्हणजे हा जो प्रिझम आहे तो बेसिकली डिपेंडिंग अपॉन इट्स वेवलेंथ ऑफ पर्टिक्युलर वेवलेंथ ऑफ that light, it will split that into RGB, basic 3 colors or primary colors, RGB. Okay, so this is a what you can say role of that beam splitter. Then now we will talk about the sensor, that imaging device. So what is and this is the major, because without sensor it is not possible to record that image. Okay, you have aperture, okay, you have a beam splitter, okay, but whatever the light, right, that is or that light is nothing but your image. Actually that light is nothing but the reflection from that object. ज्या ऑब्जेक्टची तुम्हाला इमेज घ्यायची आहे त्या ऑब्जेक्ट पासून तो लाईट रिफ्लेक्ट होतो आहे त्याचं ते recording आहे. So this imaging device is very very important part in any video or in what you can say in video camera also, and in your normal camera also. Imaging device is very very important. So it is a transducer which converts light energy into electronic signal. बरोबर आहे. हा एक प्रकारचा ट्रान्सड्युसर आहे. तो काय करतो, लाईट एनर्जीचं इलेक्ट्रॉनिक सिग्नल मध्ये कन्व्हर्जन करतो, राईट. इट कंटेन्स मिलियन्स ऑफ इमेजिंग सेन्सर एलिमेंट्स कॉल्ड पिक्सेल्स. बरोबर आहे. आपण इमेज ॲक्विजिशन्स in unit number first, when we are talking about the image acquisition, then we have studied different sensors, right? Sensor strip, sensor array, single sensor device. So it having the millions of imaging sensors, means it having that such a millions of single sensor fitting to form the array, right? Or it can be a millions of such a sensing arrays that are fitted together, right? So this is about the imaging device. Now normally CCD and CMOS are the most widely used imaging devices. Okay, so this is how this what you can say imaging devices work. So after that beam splitter, you have that red, green, and blue light. Okay, then you have that dichromic prism, right? So that dichromic prism, what it do? It will again split that RGB light. Okay, and it will divide that light, right? That means the first red light will go to a first CCD sensor, then that second green light will go to a second CCD sensor, and the third blue light will go to that third CCD sensor. So that dichroic prism will able to split that RGB, right, depending upon its wavelength and speed to its respective sensors, or it will help that light to reach to its respective sensor. So this is how the imaging devices are or the imaging sensors are able to capture the image. Now what is the viewfinder? So there are two types of viewfinder. First one is a monochrome and second one is a color display. That means your LCD. It represents image what our camera lens sees. That means the viewfinder is nothing but now okay. Now we have captured our image, but how, what we have captured, म्हणजे आपण जे कॅप्चर केलेला आहे जो ऑब्जेक्ट, ते आपल्याला पाहण्यासाठी we must require a viewfinder. That means that can be of monochrome or that can be of color display. So this is what the viewfinder is used for. Okay, and the size varies according to their uses. So this viewfinder, their size varies according to your uses. तुम्ही डिजिटल कॅमेरा बघितला असेल, डिजिटल कॅमेरा सुद्धा तो एक एलसीडी स्क्रीन असते, बरोबर आहे का नाही? त्याच्यात तुम्हाला दिसतं की तुम्ही काय, कुठला काय तुम्हाला कॅप्चर करायचंय, राईट? ते तुम्ही आधी त्या एलसीडी वर बघता किंवा काय कॅप्चर केलंय हे नंतर तुम्ही त्या एलसीडी स्क्रीनवर बघू शकता की फोटो तुमचा कसा दिसणार आहे. सो दॅट इज द व्ह्यू फाइंडर ऍक्च्युली. ओके, देन यू हॅव स्टोरेज डिव्हाइसेस. ओके, जुन्या जुन्या इन ओल्ड एज you have cassettes, then you have beta sp tape storage, then memory sticks, then you have a cd rom. Nowadays you can use your sd cards. Okay, so there are different types of storage depending upon the analog or digital. You can choose any one. Okay, now working of video camera. So you can able to see this presentation and you will get, see, first the reflected light is captured by the lens, then it is reached to the beam splitter, then after beam splitter it is reached to the dichromic filter and it is divided into RGB. Now your CCD has captured the image. Again you can see this presentation. Light is reached to the lens, then it is reached to the beam splitter. Beam splitter will divide into a RGB, then it will reach to a dichromic dichromic prism. It splits that RGB to the its respective CCD sensor. That means 3 CCD imaging sensors we are using. And but obvious the next job it is stored into a storage device. दिसतंय का सगळ्यांना वर्किंग?
Yes, sir.
See, in between that lens and splitter, again we have that what you can say shutter, and we have that that two parts are also there. But the main parts are this lens, beam splitter, and CCD. That means imaging sensor. त्या लेन्स आणि बीम स्प्लिटरच्या मध्ये परत ते शटर आणि वगैरे असतं. बट these are the major parts, you can say. Okay. Now these are the external parts of the camera. Okay. Now what are different external parts? See, there are some internal parts, there are some external parts. So this is what the external parts of camera. So you have that viewfinder, LCD screen, then you have different buttons to change the automatic manual mode. So you have lens, but obvious lens is there. To record the voice, you have a mic, right? Then you have a mini DV tape holding component. That means if you want to record and store, you have that to insert the tape, right? Nowadays everything is digital, no one uses that tape and cassette. Okay, everything is recorded into your SD card, right? You have that SD card in your video camera or your normal camera, and you record everything on that SD card. Okay, and so even some of the video cameras have their own storage internal memory also. काही काही कॅमेरानं त्यांची स्वतःची पण मेमरी असते, त्याच्यात ते स्टोअर करतात. So these are the some external parts of the camera. Okay, now video signal. Now we have discussed about the video camera, how it works. Okay, now we will talk about the video signal. Now what do you mean by video signal? So when we refer to a video, we are actually referring to a sequence of moving images. Each is a perspective projection of a 3D sense onto a 2D image plane. म्हणजे जर का आपण, सी, we have talked about the single image. आपण जेव्हा आतापर्यंत इमेज इमेज म्हणतो, म्हणजे वी हॅव टॉक्ड अबाउट अ सिंगल 2D इमेज, बट when you have a sequence of such a different images one by one together, then you can have the video signal. That means, what do you mean by video signal? Video signal is nothing but a sequence of moving images, and that all images are moving. That all images are moving. Sequence of moving images. Each is the perspective projection of a 3D sense onto a 2D image plane. This is a simple definition of video signal. And normally we refer to a point in the image plane as a pixel or cell. बरोबर आहे. इमेजच्या बाबतीत आपण जो एक त्यातला पॉइंट असतो त्याला काय म्हणतो? पिक्सेल. Especially when we talk about a digital imagery. Okay. Now progressive and interlaced scan. Now, what do you mean by progressive and what do you mean by interlaced scan? So, the slide present two different ways of sampling a video signal. That means this progressive and interlaced scan is used for the what you can say a sampling purpose, sampling of a video signal. One is a progressive and another is a interlaced scan. So, with progressive sampling, video signal is sampled as a sequence of complete video frame, right? So just like what you do in your normally sampling. म्हणजे सपोज तुमच्या एका व्हिडिओमध्ये सपोज यू हॅव 10 डिफरंट इमेजिंग फ्रेम्स. जर का 10 तुमच्याकडे इमेजिंग फ्रेम्स आहेत, तर 10 कंटिन्युअसली मुव्हिंग फ्रेम म्हणजेच त्याला आपण व्हिडिओ म्हणतो. बरोबर आहे. व्हिडिओ म्हणजे काय असा वेगळा पार्ट नसतो. 10 फ्रेम्स जर का तुम्ही फॉर एक्झाम्पल सपोज तुम्ही एक ट्रेन तुमच्या समोरून जाते, बरोबर आहे. तर दोन बोग्यांच्या मध्ये थोडीशी स्पेस असते टू कनेक्ट दॅट. पण जेव्हा एखादी ट्रेन फास्ट जाते तुम्हाला ती स्पेस रेकग्नाइज होते का? तुम्हाला त्या दोन बोगीच्या मधली किंवा दोन कोचेसच्या मधली स्पेस रेकग्नाइज होते का जेव्हा एखादी फास्ट जाते? ते असे कंटिन्युअस बोगी एकच असल्यासारखी वाटते का नाही? थ्रूआउट द फ्रॉम फर्स्ट कोच टू द लास्ट कोच ती एक कंटिन्युअस बोगी असल्यासारखी वाटते का नाही तुम्हाला? तुम्हाला ती स्पेस रेकग्नाइज होते का? सपोज फास्ट ट्रेन सपोज तुमच्याकडे गेली, यू आर अनेबल टू रेकग्नाइज दॅट स्पेस अँड दिस इज द व्हिडिओ. पण ऍक्च्युअली काय असतं, त्या 10 to different 12 bogies are connected with each other. 10 to different 12 bogies are connected with each other. त्या सेम सिक्वेन्स मध्ये ती प्रत्येक बोगी म्हणजे एक फ्रेम असते आणि अशा अनेक फ्रेम एकमेकांना कनेक्ट केलेल्या विथ मुव्हिंग स्पीड दॅट फॉर्म्स द व्हिडिओ, राईट. सो with a progressive sampling, a video signal is sampled as a sequence of complete video frame, just like what you normally do with the sampling, right? But with interlaced sampling, now what is the difference in interlaced sampling? In interlaced sampling, we keep only half of the information in a complete frame each time, right? We keep only half the information, right, out of complete frame. Now, in progressive and interlaced scan, since the filled picture have a lower video resolution, they are normally sampled twice more than the frequency. बरोबर. सॅम्पलिंग थेरम काय सांगतो आपल्याला? एफएस सॅम्पलिंग फ्रिक्वेन्सी शुड बी, व्हॉट इज सॅम्पलिंग थेरम? What is sampling theorem? Fs is greater than or equal to
2 FM. Not getting signal.
very good. Fs is greater than or equal to twice of the FM. That means your FM is your baseband signal. म्हणजे जी तुमच्या व्हिडिओची जी सॅम्पलिंग रेट आहे किंवा व्हिडिओचा जो स्पीड आहे, व्हॉट यू कॅन से, त्या ज्या फ्रेम्स तुम्ही एकमेकांशी कनेक्टेड केलेल्या आहेत त्याची जी फ्रिक्वेन्सी आहे किंवा त्याचा जो स्पीड आहे त्याच्या ट्वाइस हा एवढा तुमचा सॅम्पलिंग रेट पाहिजे किंवा त्याच्या ट्वाइस हा तुमचा सॅम्पलिंग रेट पाहिजे. अँड दिस इज अ स्टँडर्ड, राईट. इफ यू डोंट यूज then you know what will happen. Overlapping is there, right? Overlapping is there. So sampling frequency should be greater than or equal to twice of the FM. Okay, so you go for progressive sampling or interlaced sampling, but you have to always follow the sampling theorem. Okay, now next part is a this is about the this main difference between the progressive sampling and interlaced sampling. Okay, now let me go to the next slide. Okay, this part I have to show you. Okay, the scanning in what happens, see, you have a screen, right? It must have some width, it must have some height, it must have top, it must have bottom. Then how actually your video is getting on your screen. So it always starts from the left most top corner. म्हणजे डाव्या बाजूच्या त्या टॉप कॉर्नर पासून तो व्हिडिओ स्क्रीनवर दिसायला सुरू होतो. अँड हाऊ दॅट स्कॅनिंग इज डन. सो इट विल ऑलवेज ट्रॅव्हल फ्रॉम लेफ्ट टू राईट. Then again that particular what you can say anode diode will come back to the again light. Then again it will travel from left to right. Again it will come. That means the first travel is known as trace, and second travel, that means from right to left, is known as retrace. And this is how your actually what you can say video is appearing in your screen. Video is appearing in your screen. Now you have the horizontal scanning. Now what do you mean by horizontal scanning? The linear rise of a current, in a horizontal direction coils that deflates the beam across the screen with a continuous uniform motion for a trace from left to right. म्हणजे horizontal scanning म्हणजे काय? It is in horizontal direction from left to right or right to left. That is trace, retrace, trace, retrace, right? This is known as horizontal line. Okay, trace म्हणजे काय? It will what you can say go from left to right, and retrace means what? It has to come back to its original position, and then again it will produce a line. That means horizontal scanning. So trace is nothing but horizontal scanning. Retrace means what? It has to come back to its original position. Okay, now actually this part you are going to discuss in the your next semester. That is, you have one subject MCT, right? So in that MCT you are going to study the working of the video camera and screen, everything in detail. So this is just introductory part, right? This is the about horizontal scanning, start of the line, end of the line. Okay, that means see, the first line, the what you can say, the field line is trace and the dotted line is retrace. Now again field line is trace, dotted line is retrace. This is the start of the line, end of the line. Again here, start of the line, end of the line. This is how trace, retrace, trace, retrace, and you can have the over full picture. आणि हे असं पूर्ण स्क्रीनवर ट्रेस रिट्रेस करून असतं, and you can able to see that entire frame into your screen, and such a moving entire frame continuously will form the video. Such a moving entire frame continuously will form the video. And this is how the video will appear in front of your screen. Now we will talk about the vertical scanning. This is the horizontal scanning, trace, retrace. Now what happens in a vertical scanning? So the current in a vertical direction of coils. So in that behind that screen there are some induction coils, right? That actually flows the current from, or that will fetch the current from left to right and again from right to left. That means trace and retrace. So in case of vertical scanning, the current in a vertical deflection coil moves the electron beam from top to bottom of the raster at a uniform speed while the electron beam is being deflected horizontally. म्हणजे electron beam जो आहे तो trace retrace, but the current skin is like the current in a vertical deflection coil, it will what you can say stretch the electron vertically, आणि जे horizontal scanning असतं त्याच्यात it will what you can say stretch the electrons हॉरिझॉन्टली, म्हणजे ते हॉरिझॉन्टल मोशन करतं इलेक्ट्रॉनशी, आणि ज्या व्हर्टिकल कॉइल्स असतात त्या व्हर्टिकल मोशन करतं इलेक्ट्रॉनशी. अँड नाव you can have this vertical scan like this. See, this is vertical scanning, linear vertical. So this is like trace, right? It will go some down, then this is the retrace, then again it will some go down. This is the horizontal, as that means what you can say, whenever the picture appears in front of your screen, so it is a combination of horizontal scan and vertical scan. असं काही एक कुठलं वापरू शकत नाही तुम्ही. ते तुम्हाला हॉरिझॉन्टली पण स्कॅन करायचं असतं आणि व्हर्टिकली पण स्कॅन करायचं असतं, अँड दॅट बोथ विल फॉर्म द एंटायर व्ह्यू. दॅट मीन्स appearing any video or any image into your screen is a result of horizontal scanning and vertical scanning. Horizontal scanning आणि vertical scanning चा तो result असतो. Okay. Now, this interlaced scanning that we will cover in next lecture. Okay. Today we will stop here. If you have any doubt, you can ask me right now. So probably within in next lecture we will finish this unit number 6 also, and then we will start with the unit number 7. If you have any doubt, you can ask me right now regarding this unit number 6. Otherwise, we will stop here. Any doubt? Any doubt?
No, sir.
Okay.